This is a video for MEI Core Pure Mathematics, second order differential equations 2, non-homogeneous equations, 2.1, finding the complementary function. So to solve this second order differential equation, which is non-homogeneous if this function on the right hand side is non-zero, we first solve the homogeneous version of that equation. In other words, we put it equal to naught and solve it as we have done before. Its general solution we now call the complementary function because it only forms part of the general solution for this non-homogeneous equation. So if we want to solve this differential equation, we start out by forming the homogeneous version of it, so we just put it equal to 0. So this thing minus 2y is equal to naught. We then look at the auxiliary equation for that, and the auxiliary equation for that is m squared minus m minus 2 is equal to naught. That factorizes into m minus 2 m plus 1 equals naught, and that gives me two real roots, m is equal to 2 and m is equal to minus 1. And so my complementary function, which I'm going to write as CF from now on, my complementary function is going to be y equals a e to the 2x plus b e to the minus x. There's that written up a bit more neatly. There's the confirmation that we look at the homogeneous version of this differential equation first of all. From its auxiliary equation, we get the general solution for that becomes the complementary function when we solve the non-homogeneous version up here. So if the complementary function is this, then we know that this is equal to naught. And you could verify this by differentiating this a couple of times and plugging everything into here to see that you do in fact end up with 0. However, we want to solve this thing, which is not equal to naught but is equal to 3x plus 4. And so we therefore need to add another function to the complementary function. And this is called the particular integral. And again, we're going to give that letters. We're going to call that pi. Now in this particular example, the particular integral turns out to be this function, minus 1.5x minus 1.25. And so the general solution for the whole differential equation is equal to this. And again, you could verify this solution by differentiating a couple of times and plugging everything into this equation up here and seeing that it does actually work out. So in general, if we're solving a non-homogeneous second order differential equation like this, the first thing we do is we find the complementary function, CF, and that's using the auxiliary equation just as we have in previous videos. We then need to add in the particular integral, which is a function which is determined by what we need for the right-hand side in the differential equation. We're going to look at how we do that in the next couple of videos, and then the general solution becomes the complementary function plus the particular integral. The next video in this sequence is 2.2, using a trial function to find a particular integral.